Okay, recording started. One is
Start okay, sir. Recording.
Your
recording started, sir.
Recording started. Now you can start.
So shall we start, sir? Now?
Yes.
It's 8:58.
Mm-hmm.
Very good morning to all the participants. On behalf of Shram Sadhana Bombay Trust, College of Engineering and Technology, Bambhori, Jalgaon, I, Mr. Amol Vani, Assistant Professor, Electronics and Telecommunication Engineering Department, and ITISA Faculty Advisor, welcomes you all to this online international seminar on energy transition and energy technologies, organized by Electronics and Telecommunication Students Association, abbreviated as ITISA, of ENTC Department. SSBT's College of Engineering and Technology, Jalgaon, established in 1983, is one of the leading institutes in Maharashtra, having long established tradition of quality education. ITISA of Electronics and Telecommunication Engineering Department is a students organization having objective to provide platform and enrich students with different qualities and skills for their overall development by regularly organizing various co-curricular and extracurricular activities that contribute to the academic and professional growth of students. In this COVID pandemic, also ITISA has organized various online activities like webinars, workshops, and many others. Dear participants, the demand for energy is increasingly growing, leading to increased carbon emission and global warming. To reduce this, the energy transition is crucial for our future. It is a significant structural changes in an energy system, moving towards renewable electricity to help meet global climate targets, for which we should understand the energy technologies concerned with developing systems capable of producing and delivering safe environments. Hence, to understand such a very important topic, we have organized this seminar, Energy Transition and Energy Technologies, by our speaker, Ms. Atwongyeire Jain Reus, geoscientist, Prince of Songkhla University, Thailand. I welcome you, ma'am. Now, I call upon Professor Dr. PJ Shah, convener of today's seminar, to preface and introduce our speaker. Over to Shah, sir.
Thank you, Mr. Amol Vani. Good morning and welcome to the program. Today's speaker of the program, Ms. Jain Rose Atwongyeire, geoscientist, Prince of Songkhla University, Thailand. Dr. Arkam from Prince of Songkhla University, Thailand. Our principal, Dr. K.S. Vani sir. Vice Principal, Dr. S.P. Shekhawat. Head of Department, Dr. S.R. Surarkar, Mr. Amol Vani, and all faculty members, and my dear students. Student Association of Electronics and Telecommunication Engineering Department is organizing one-day international online seminar for the students on energy transition and energy technologies. The main objective of this program is to update the students with the present technology and overall development of the student. Around the world, lockdown measures to contain COVID-19 have led to economic contraction and significant drop in energy consumption, including electricity, gas, and oil. Expert and policymakers still are taking a stock of impact of COVID-19 on the energy landscape and what is meant for the ongoing transition to sustainable energy. The energy transition is the pathway towards a transformation of a global energy sector from a fossil base to zero carbon by the second half of the century. At its heart is need to reduce energy related to CO2 emission to limit a climate change. Our today's speaker will enhance our knowledge on this topic. SSBT has signed MOU with Prince of Songkhla University, Thailand before 2 years. Under this MOU, college has conducted many programs for faculty members and students also. And this is one of the program. Now, it is my privilege to introduce today's speaker, Ms. Jane Rose Atwongyeire. Jane Rose is geoscientist in sustainable energy management for sustainable development. She received scholarship by Thailand government for her MSc in sustainable energy management at Prince of Songkhla University, Hat campus, which she has completed. She has completed a bachelor degree in petroleum and geoscience production at Makerere University, Kampala, Uganda. She was work at a National Environment Management Authority, NEMA, Uganda. She has also worked with AKEM Consulting Company Limited, Uganda. She has published various research papers in renowned journals. She is also reviewer of the various journals. My special thanks to Jane Rose for accepting our invitation and joined today from her busy schedule. And also thanks to Dr. Arkom for his continuous support. My best wishes to all participants. I hope you will take the advantage from this seminar. Thank you very much and Jai Hind. Over to Mr. Amolwani. Amolwani, sir.
Thank you, sir. Now, moving towards our program, I request our today's speaker to please start the session.
Please share your PPT, ma'am. Yes, visible.
The College of SSBT, Engineering and Technology, India. Thank you so much for today. Thank you for the opportunity to be here to share my knowledge with the students. And to save time, I'll just go straight into the presentation. Today's seminar is about energy transition. I hope I'm very audible.
Yeah, madam.
Okay, please let me know where I'm very fast or very slow, or you cannot understand me.
Yeah.
Thank you so much.
Thank you.
Yes, the presentation is energy transition and energy technologies, but we'll basically focus on smart grid for enhancing power generation and distribution from renewable energy resources, combined with multi-criteria decision making and geographic information system approaches. Like earlier, I introduced a little bit of myself. I'm a geoscientist. who has currently finished her master's degree in sustainable energy management at Prince of Songkhla University. And my background undergrad is petroleum and geoscience production at Makerere University, Kampala, Uganda. I previously worked at National Environment Management Authority in Uganda as an apprentice under Oil and Gas Department. And I also worked at a chem consulting company as a data assistant. I have reviewed a few journals and I continue to grow my career in energy and management. So as for the topic today, energy transition. When we talk about energy transition, there are a few questions that may come in one's mind. I don't know if our students, some may know actually what energy transition is, and some may typically not know what energy transition is. But why energy transition, and what has triggered energy transition, and what is the way forward? So energy transition basically is the new term that has been coined in the recent years to paint a picture of moving from fossil-based power generation to renewable energies due to the recurring issues and concerns. And some of those include climate change, they include energy insecurity, they include energy efficiency, they include the demand. We all know that the world population, forgetting about COVID-19, we know that the world population is growing at a very fast rate, which also means increasing demand of energy. And those are some of the things that have triggered the transition: the climate change, the environmental impact concerns. When we look at the global situation right now, the oil industry, it all, in the recent years, we have had so many impacts environmentally. We have heard of wildfires, we have heard of prolonged droughts in some countries, we have heard of heavy rains. So it affects the globe differently and different environments. So we cannot say that, okay, in India, we are going to manage climate, and Uganda or Thailand will not manage climate, and it will only affect, one of the areas. When one does not take heed, all of us are affected, and we are affected differently, some positively and some negatively, which has triggered the global unity for us to move into better solutions for our energy sector. And the way forward is energy technologies. But what is energy technologies and what is it about? So energy technologies is basically an interdisciplinary engineering discipline that focuses on energy efficiency, energy use, energy utilization. It focuses on storage. It focuses on environmental friendly, solutions. It focuses on low carbon, climate change factors, and etc. So why do we need energy technology? First of all, like I said earlier, the population of the world is increasing. And that means there is global increase in demand. So one of the reasons why we need energy technology is higher global energy demand. The limited energy resources, we all know that fossil fuels are infinite resources. They are depleted. When we remove from the soil, we do not put back. So we are not guaranteed by the energy security when it comes to fossil fuels, which on the other hand, with renewable energy, as we are going to dig deep later, it assures us of energy security. Another issue is low energy conservation efficiency. And another one is low energy utilization efficiency, global warming, climate change problems, and fluctuation in energy cost. So when we talk of energy trending technologies, what is that one technology that is trending right now? that is renewable energy technologies. These include solar, they include hydro, they include wind, they include biomass, hybrid resources. But I'm going to challenge you today because the world is so much focused on renewable energy resources and technologies for the answer to climate change and energy securities, which I want to agree and disagree for some reasons, because in thousands of years ago, when fossil fuels were discovered for energy solutions, no one knew of what was to come. No one knew that would have climate change issues. No one knew that would have energy insecurities. No one knew that would be right now fighting carbon emissions. So even though we are moving into renewable energy technologies, in as much as we know they're clean alternatives, we all know that they have their own disadvantages and advantages. So I want to challenge our students today, whoever is listening in, that in as much as we are going to talk about the trending energy technology, renewable energy technologies, I want to leave you with a question and something to think about, that in the 100 years to come, you may be alive or you may not be. What will be renewable energy? Because I believe we need to dig deep. In as much as we're excited about the solutions and the answers renewable energies are giving us, we are not guaranteed of the future. It has its own associated issues. When we look at, for example, solar, we have solar panels. Have the world come to the management of solar waste? That is one of them, but that is not for today. I want you to think about it. I want you to ponder that in as much as we are excited about renewable energy, we need to move faster than the resource itself, because we do not know the future ahead, just like we did not know for fossil fuels. So how do we deal with the dynamics in the energy environment? Like I said earlier, renewable energy technologies, renewable energy resources, yes, they give us answers, but they have their own issues, intermittent nature. For example, when it rains, you're not guaranteed of solar. When the water levels go down, you're not guaranteed of hydro. When we do not have the wind, you're not guaranteed of wind energy. Biomass, if we keep cutting trees and we have long droughts, you're not guaranteed of biomass. You know what I mean? So how do we deal with these dynamics that come with renewable energy technologies? As we all know, our system has always been a traditional system, from power generation, transmission, distribution to consumption. That is a straight chain. But can our renewable energy technologies be integrated into the traditional system without being disrupted? Of course not. We will have disruptions, because the idea of the traditional method was to just provide electricity and energy access. But now, as we advance and we go into energy transition, that calls for more, more than energy. It calls for efficiency. It calls for flexibility. It calls for reliability. As we said, fossil fuels cannot be relied on because anytime can be depleted. Energy systems, so we need to have systems that are very smart, flexible, reliable, affordable, that can accommodate clean energy, because right now that is our focus. So that calls for the technologies that are right now in the boom, and they are so many. We have so many concepts that have come for the energy systems for us to transit from fossil fuels to renewable energy or to clean alternative energy resources. And this has come with energy storage systems. This has come with so many smart energy systems, low carbon and clean energy systems. So as of the focus of today, we are going to look on one of the concepts among the many concepts. I'm going to leave you, I don't know if you're taking notes somewhere, I'm going to leave you with some of the things that you should go and read, understand, and know, because we are not going to talk about them today, but you need to know them. So among the concepts, we have smart grid, which is our focus today. And others, we have Internet of Energy. Others, we have blockchain energy. All these are things as students, as professors, we need to dig deep and understand as we move forward to providing solutions to the world for the energy transition. So today we are going to discuss or talk about smart grid for enhancing power generation and distribution from renewable energy resources, combined with multi-criteria decision-making method and geographic information system approaches. So what is basically a smart grid? I will not give you a precise definition because there are so many definitions for a smart grid. And this depends on the need of the country, the need of the organization, or any smart grid interested parties. But in simplicity, a smart grid is an innovative information communication technology driven, flexible two-way connective power system. And this system is flexible, it is affordable, it is reliable, it is efficient, it is sustainable, among others. This is one of the ways to manage our energy, to be able to achieve so many things that we are looking at as we are in energy transition. A smart grid, first of all, among other things, it is able to accommodate renewable energy resources, centered and distributed, centralized systems and distributed systems. This is one of the benefits of smart grid, as we are going to see ahead. And also it allows interaction between the producer, the consumer, and the prosumers. You know, power generation, the consumer is able to know that this much is being generated. The prosumer is able to know this much I have generated and this much I am using. That helps them to manage their energy. So one of the concepts is a smart grid that looks at transmission, that looks at distribution, that looks at consumption, that looks also into power generation. So another thing about smart grid is that it is one of the concepts that right now the world has concentrated on because of its benefits. And some of the noble countries that have enrolled in the system, mostly developed countries, it includes the United States, Canada, Australia, China, among others. However, in as much as we have those noble countries and those noble states that have enrolled the smart grid, we have so many others that are lagging behind, especially developing countries. So like I earlier explained, this is just a concept of a smart grid. As you can see, the interaction of power generation, when you look at power generation, the red, I don't know if you can see, we see the red connection is the traditional way of power transmission, from power generation, transmission, distribution to the consumer, just one way communication system. But when you look at the smart grid, we have an interaction between all systems. We have power generation, we have power transmission, we have distribution, we have consumers and prosumers, and we see the interaction, you know, of information and flow of energy. A consumer is able to understand how power is being used at his home, and he is able to interact and see how is the market, how can I be part of power generation, how can I be part of transmission, how can I manage my energy resource. And like earlier said, the designs depend on the target of the organization, of the country, of the participants, the way you need your smart system. Some already have enrolled in smart meters, basically targeting real data income, you know, to know the supply and demand, to manage supply and demand. Some who have already moved states of real data. They are now into security, cyber security, and these others. It all depends on the target of that country, what issues they have to run. Some countries, it is about accessibility of power, as we are going to see some of the case studies. Some are looking at power accessibility, so they enroll in distributed power generation. So some of the technologies about the smart grid, these are generalized. I did not pick piece by piece. So we have communication integration. These basically look at data acquisition. They look at protection, control, usage of interactive electronic devices. Then we have sensing and measurements. These technologies support data acquisition for integrity assurance of the grid, real-time reads, bill estimates, energy safety, etc. Then we have advanced components for basically monitoring the behavior of grid, both on-grid and off-grid. Then we have advanced control. These analyze, they diagnose, they predict conditions and power, like power outages, system threats, and the likes. Then we have improved interfaces for interaction of information, like earlier I showed you. There is that interaction of information inflow, where the consumer, the prosumer, and the producer are able to see the flow of energy information to be able to make right decisions in the energy management. So we have the traditional grid and we have a smart grid. Like earlier explained, when we look at the traditional grid is right now what many countries are using, the conventional grid. One of the advantages of a smart grid over the traditional is digital operations. For the traditional, we have manual operations, electrochemical, mechanical operations. For the smart grid, we have two-way communication. For tradition, we have one way, straight from power generation to consumption. But for a smart grid, we have that interaction of information. Then for smart grid, it allows distributed generation. At the same time, it allows centralized, but the traditional only focuses on centralized power generation. Then we also have limited control in the tradition, and on the other hand, in smart grid, we have pervasive control. Then we have moderate services in traditional. In smart grid, we have high quality services. When it comes to failures, threats, blackouts, a smart grid is more adaptive because it is able to foresee those threats and combat them. We have manual monitoring on traditional, but for smart grid we have self monitoring according to the design of the system for the concerns or target or needs of the system. Then we have manual restoration for traditional, where we have people driving thousands of kilometers to rectify the issue in a certain district. And yet for a smart grid, you just go to the control center and see the threat, and you're able to take care of that. So we cannot talk about energy transition, we cannot talk about smart grid concept without talking about energy planning, which brings us to multi-criteria decision-making methods and geographic information system. First of all, what is a geographic information system? It is a tool that can integrate different types of data relevant to specific locations in defined areas. It is a tool for site selection. It is a tool for energy planning. It is a tool for energy sector management. It can identify factors that are likely to affect any project besides renewable energy project, which is our focus today. But it has those abilities to gather spatial data. It is very important in distributed distribution system management because it it is location specific. So it is able to aid the process of foreseen situations or instances. When we talk about a geographic information system, you don't just talk about it. It must be suitable for the purpose you need it for. For this seminar, our smart grid concept, we have looked at the needs, the target need. We are going to focus on planning, and you cannot talk about planning for renewable energy resources without site selection, without potential identification of the renewable energy. So how can we identify that? We all know that the energy sector is very diverse. It is interdisciplinary, it involves many stakeholders and decision makers. And among many methods, I am not going to talk about thousands of them. I'm just going to talk about the commonly used methods for energy planning. And one of them is analytic hierarchy process, as well as fuzzy analytic hierarchy process. We'll come to those details later. A multi-criteria decision making. Many people, when you talk about multi-criteria decision making, they think of just theories. They think of just, techniques. But a multi-criteria decision is more than a collection of theories. It is more than techniques. It's more than the method, but it is a very specific perspective to deal with complex decisions, which makes it an ideal method, especially for energy planning, which involves many stakeholders. So these are just some of the GIS environment where we have to deal with data layers and data information, interaction of using data to arrive to the need. A multi-criteria decision process is simply, I've just summarized it in this way. So first of all, you must know what decision am I making? Is it for a vaccine? Is it for water supply, electricity supply? For our case, it is about renewable energy. So you must define the objective of your study. You must define the criteria you want to follow to get that result that you need at the end. You must select the possible alternatives that you can meet, to meet your objectives. The priorities, you must set your priorities and select a suitable method for your need. And there's so many methods for multi-criteria decision-making, like I said, but today I'm just going to focus on two: analytic hierarchy process and fuzzy analytic hierarchy process. So today our study, to highlight a few things that we have discussed and talked about, is Western region of Uganda, which was actually part of my study for master's degree. Western region of Uganda covers an area of 55 to 76.6 square kilometers. It has a population of over 8 million people. It is rich in renewable energy resources. And before I talk about its potential, the issue of the region that we chose is basically no access to electricity. I don't know if many of you or some of you know, but as the rest of the world is talking about energy access and light, Africa is one of the continents that actually some people have termed a dark continent. Why? Because many people have no access to electricity, which inspired the study in the Western region of Uganda, saying that the largest population has no access to electricity, and the poor infrastructure that inspired smart grid. The reason we chose Western region of Uganda, its uniqueness and the abundance of resources. Uganda is one of the countries that is blessed with abundance of renewable energy resources, from solar to hydro to wind to biomass, and among others. But the uniqueness of Western region of Uganda is one of the regions that has all the mentioned resources. It's amazing how it has geothermal, it has hydro, it has solar, it has wind, it has biomass. And still we have a population that is suffering from electricity access. It's ironical. So that is one of the reasons that inspired us studying the Western region of Uganda. So this is the flow of our study, the method we followed. We used a fuzzy analytic hierarchy method and geographic information system. As we follow through the methodology flow, our objective was to select suitable sites for power generation from solar and hydro using smart grid approach. We collected the data, we generated data based on the criteria, and then, sorry, am I still audible?
Yes, audible, don't worry.
Thank you. So as we are going to see in details, kindly follow through the flow of our methodology. So we used geographic information system and fuzzy analytic hierarchy process. The criteria used was economic, environmental, and technical. Sorry, there's a technical error here. It is technical, not economic and economic. Then we use data, as I'm going to show in the next slides. And then we considered a number of experts. So the data that was collected was based on distance from roads for economic criteria, distance from transmission lines, and topography. Then for environmental, we looked at land use, we looked at sensitive and protected areas. For technical, we considered distance from demand centers, availability of energy resources, and climate. Under technical, we considered distance from roads, distance from transmission lines, and topography. As we all know, when setting up a power plant, the location is very important. How accessible is that place, and how easily can we transmit the power, and how suitable is the topography, because all that adds to the cost of implementation and development of the project. Then environmental land use, we focused on land use in sensitive and protected areas, because in Uganda, first of all, to do any project, you must consult with the National Environment Management Authority. And one of their mandates is to protect the environment. And in the National Act, it is very important that sensitive and protected areas are put into consideration for any project implementation and planning. So in this study, that's why it was very important for us to consider sensitive and protected areas for our project and site selection. Then land use, we needed to know the distribution, because you cannot just put a power plant anywhere. You have to consider settlements and activities of that particular area that you're interested in. Then technical, distance from demand centers. For any power planning, energy planning, it is very important to know your target demand, so that we do not have unnecessary, implementation of projects, redundant projects. Then availability of the energy resource, which is basically the reason we had to do the study, because for energy planning, why are you planning energy? It's about resources, right? To provide the need of your target. And then climate, because we were looking at solar and hydro in this case. In our study, data was collected both online and institutions. We got some of the data from online port sources and data from institutions, some of the institutions in Uganda. We considered 10 experts for this study, and some of the experts included professionals from power generation, power distribution, power transmission, national energy, National Environmental Management Authority, because environment again, and academia that are in the energy field. So in the study, like I said, we used a fuzzy analytic hierarchy process method. What is analytic hierarchy process method? This is one of the multi-criteria decision-making method that uses significant factors to show or to rate the need or the importance of those particular factors or criteria that you chose for your study. This is a table of scale that actually was used to get opinions and comments from our experts rating the criteria and why they rated that criteria based on a questionnaire. So we designed a questionnaire based on this scale and based on the criteria to get comments and opinions from those experts if these factors are relevant for our study or not. So the first part of us of the scale, as you can see, 1, 3, 5, 7, 9, 2, 4, 6, 8. That is basically the multi-criteria AHP scale, where the experts had to rate, for example, 1. If you give economic 1, environmental 1, technical 1, it just means that all the factors have the equal importance. If you give 3 for environmental against economic, it means environmental is 3 times weaker than economic. Then because we are using the fuzzy AHP, which is just a manipulation of the AHP because of the limitations that are associated with AHP method, that is analytic hierarchy process. Analytic hierarchy process, in as much as it's a very convenient process, it has its limitations. First of all, different experts have different opinions based on their fields. But using the fuzzy, it helps us accommodate those ambiguities where the expert may rate according to his interest. And that's why we use fuzzy triangular numbers, as we can see. So in our study, after getting the rankings, we calculated the weights of the sub-criteria and the criteria. After calculating the weights were used in the GIS environment to create layers of roads, layers of transmission lines, layers of topography, layers of resources, layers of demand centers, administration boundaries, and etc. And these layers were used to, first of all, identify the solar potential areas. In our study, solar potential data was actually determined, and then we used already existing data for small hydro power potential. So we used the layers to determine and identify potential areas for power generation from solar, and then the available data for hydro was combined in GIS. These are the results that we achieved. So I know most of you are wondering, you said you used fuzzy AHP, then why do you have AHP? We calculated using the same methods because many studies have showed that AHP cannot be relied on due to the differences in expert opinions, and fuzzy AHP takes into account those issues. But in this study, we wanted to clarify and verify, are there ambiguities in the decisions or in the opinions of the experts, or they are as accurate as the decisions we are going to take. So that's why we calculated for both, and from our results, there was just an insignificant difference. As you can see, it's in 0.000 something. So which means both the experts' opinions, they can be relied on in this site selection. So these are the weights for the sub-criteria: land use, distance from protected areas, from roads, distance from transmission lines, topography, distance from demand centers, available solar and hydro potentials, and climate. As you can see, still we calculated for both methods because we wanted to be sure, is there a difference? Can we rely on the opinions from the experts, or there are some ambiguities within their opinions and comments? So as you can see, graphical expression, a representation, you see there is not much difference. So we can conclude that actually the comments from the experts can be relied on in this case for this study. It's not the case for all the studies, but for this study, we can rely on their opinions and comments. So these are sites selected for solar potential areas. As you can see, the purple represents low suitability, the yellow moderate suitability, and the red for high suitability. As you can see, Uganda is, endowed with high potential solar, especially for this study. So as we can see, the rating, the yellow, the purple, and the red, in our GIS, we considered 1.4 hectares for 1 megawatt. So it's according to the hectares that we generated these kinds of megawatts. I know some of you might ask questions, why do you have an anonymous number? It's very big, but it's because of the assumption that we used in our study, as we can see here. And one of the districts that has the highest solar energy potential in this study, as it was revealed, is Chirhura district. And then Kisoro, Rwanda, they have the low solar potential in this study, as it is indicated. But our study was not to just determine area potentials for solar, it was to determine suitable areas for smart grid application for distributed power generation for solar and small hydro. So we combined the layers in a smart grid in GIS environment, solar obtained potential sites and available data for small hydro potential. And we grouped the areas into 3 because it is big. And as we know, renewable energy resources are distributed in different locations. So for our study, we considered the factors that weighed higher in the expert opinions to generate suitable areas for smart grid. This is just a site selection, which I will come to at the end, that our study has its limitations because this is just a site selection, not including the technologies of smart grid. But basically, as we selected the sites, in mind, we were focusing on power distribution to combat the issues of lack of electricity accessibility. So we combined the layers, transmission lines, road network, demand centers, solar, and small hydro potentials. And we generated 3 groups. We have north, we have central, and we have the south. The southern part has the highest potential of both solar and hydro. And that also, based on the factors that we considered, it is the reason it has the highest potential because of the nearness and the factors that we considered, like road network, transmission. The closer the areas, the better the smart grid application. So the southern part has 15 districts and it has the highest potential of solar and small hydro. The central has Central has 10 districts, and Kakomero has the highest potential of solar. Karoe has the highest potential of small hydro, and the northern region, which actually is the smallest of the grouping, has the lowest hydro, small hydro. Wait. Yes, it has Hoima with the highest solar potential, 37,543.6 megawatt, and Masindi with small hydro, 3.3 megawatts. As we are going to see in the next slide, these are regions. This is the northern region, as you can see. So these are hydro power plants, sites, potential areas for hydro. It just has only 3 potential sites for hydro. And then as we can see, the distribution of solar, the red is high potential, the yellow is moderate, and the purple is low. And then we have Central. As you can see, Central really has 1, 2, 3, 4, 5, 6 hydro sites. And then as we can see, the distribution of solar. And then the Southern has 1, 2, 3, 4, 5, 6 small hydro small hydro power potential sites. And as we can see, we see the distribution of solar. So this was the final result of our study, defining those areas where smart grid for distributed power generation from 2 resources, solar and small hydro, to combat the issues of electricity access in the western region of Uganda. So for our study, the target was access to electricity. After everyone has access to electricity, then we can look into further, complicated or advanced. But right now the need is energy access, and that's why we had a site selection for renewable energy resources. However, our study has limitation. First of all, we did not have site visitations. We collected data. And secondly, it uses only the AHP method and fuzzy HP. There could be other methods. And also, we did not go into the details of what technologies, for example, for solar, what technologies, for example, for hydro, or what technologies for smart grid to be used. However, these limitations are to an advantage for further research studies for energy researchers like me who wants to grow a career in energy management and energy sustainability. So with all that said, we come to the conclusion. Like earlier said in our introductory part, smart grid is one of the technological concepts that is trending in the energy sector. We have many countries that have enrolled in the smart grid concept, especially developing countries. However, our developing countries are still lagging in this. Therefore, it is very important for developing countries to consider implementation of such concept for a smooth transition of energy from fossil power generation to renewable energy. And additionally, in implementation of these projects, we need planning and implementation. That's why we had a study for site selection. However, more intensive research projects and pilot studies are very important for the appropriate selection of the technologies. And finally, it is very important for individual countries and individual governments that have not implemented smart grids to invest in the concept and the initiative of these smart energy systems for a smooth transition. I must appreciate, before I actually end my presentation, I must appreciate India. In October 2015, in one of the cities, the names are amazing, but I know it's something Jalgaon. I don't want to say the name wrongly. It is GURGEON City. They started a smart grid concept in 2015 in the National Energy Program, Transition Program in India. And as far as I'm following right now, I think it is supposed to commence 2022, if all goes well and without COVID-19. So India is an example to developing countries, especially when it comes to smart grid. And I hope students take note that smart grid in India is actually doing well compared to other developing countries. Otherwise, thank you so much, SSBT College, for today's opportunity and to share my knowledge. And more knowledge, I'm also waiting on the students. They may know more than I know. So it's very okay for you to share more that we have missed out. Otherwise, I don't know if we have any questions. I'm going to hand over to the host. Thank you so much.
Thank you, ma'am. A very big thanks for such a wonderful and knowledgeable presentation. Your seminar has really make us complete understanding of today's energy scenario and importance of energy transition and trending energy technologies and concept of smart grid. Thank you very much. Now I request the participants to please ask the questions if you are having. You can please feel free to ask the question, or you can even write us on the chat box so I can ask. There is one question for participant, ma'am. Is there any demo model of biogas and biomass energy generation plant in any software? I repeat the question. The question from a participant Ajay Patil: is there any demo model of biogas and biomass energy generation in any software?
Thank you so much for that question. However, I am going to kindly ask Dr. Akom, who is a very amazing expert in biogas. I'm not an expert in biogas and biomass energy, but Dr. Akom is an expert in biomass. So I'm going to kindly ask him to answer that question. Thank you so much.
Thanks, Jen. Thanks so much for the question also. And good morning to everyone again. I'm Akom Paramanis. So I know the Dr. Pales before. About 2 years ago, I went to visit India and this colleagues. So thanks so much for your organize today. For the question, in the case of Thailand, we have the small scale of the biogas power plant and biomass power plant at the south of Thailand. So for the site selection of the smart grid, we have the model in at the north of Thailand also. So for software, so you can put the GIS combined with the multi-criteria decision to make the decision for site selection of the smart grid. But in the case of the power plant, the simulation, you have to use the other software to generate the combination between biogas and biomass. For smart grid, of course, you can use the GIS combined with the multi-criteria selection to select the suitable site. So this is my opinion and my answer. I think it's covered the question.
Thank you, Dr. Akom, sir. We are really lucky that you are today. You joined us our seminar, and definitely you have given your answer to our participants. Any more question, please? The question is, can you please elaborate floating solar power plant concept in short? Shall I repeat the question, ma'am?
Thank you so much. I was actually writing the question here because I can see it on
Yeah.
the screen here. Thank you so much, Nalesh, for asking that question. I'm going to briefly, first of all, say that I'm not an expert in solar, but floating solar power plant concept actually started, as we know some countries, they do not have space, you know, for solar farms. So the whole concept of floating solar power plant was coined due to space. So some of solar power plants, I think like Singapore, I'm not sure, but Singapore maybe has one of the power plants. They float, they build the power plants on water, you know, on water. That is the whole concept of floating power plants. We all know that solar farms, wind farms, they take a lot of space. And some countries, they no longer have space for that luxury of thousands and thousands of pieces of land for solar power plants. So that was the concept of solar power plant, floating solar power plant. I hope I have explained the whole concept. I hope so.
Yeah, ma'am. Any more question from participant?
Good morning, ma'am.
Yes, yes. You're audible.
Earlier, ma'am has told like there are lot of need in the future of energies, and we still have limited resource. So, what step we are taking to get rid of this?
Thank you so much for your question. Probably you came in maybe a bit late for the presentation, but the reason for energy transition is actually the threat for energy security. We all know that thousands of years we are still depending on fossil fuels, which are not reliable. They are easily depleted. So that's why we are seeing the world moving and shifting to renewable energy technologies and renewable energy resources like solar. We will forever have the sun unless otherwise. We will forever have the rains unless otherwise. We will forever have the winds unless otherwise. And we'll forever have geothermal and all these renewable energy resources. So the energy threat and the lack of resources is the reason some countries, especially oil dependent countries, are also considering that it's not only oil and gas, but we are also going to venture into renewable energy resources that are infinite. You cannot finish the sun. Even if you say the whole of the world, we are going to put power plants for solar, you cannot finish the sun. It will forever be here unless otherwise. So I don't know if I've answered you. One of the reasons and one of the solutions right now for energy insecurities and how we can combat the issue of limited resources is the reason we are moving to renewable energy resources that are reliable, because we can forever have them here. Thank you so much.
One question from the participant is that what energy future should we plan for, and how long will the transition take?
Thank you for that smart question. I can tell you that I will still also ask the same question. You know, the future of energy is very uncertain, to be honest. And even if the experts say it is very certain and we can rely on renewable energy resources, it is very uncertain. That's why we are seeing many innovations and technologies that are coming up, like a smart grid that is very flexible, because we have to plan ahead. So no one knew that would be at this point when we were starting our ancestors starting thousands of years ago for fossil fuels. So I cannot say that we will change tomorrow because there are very many factors. I will give you an example. The issues of Canada or the issues of the rest of the world cannot be the issues of developing countries. I will give you the example of Uganda that I know and Africa that I know. I will not give you an example of Asia because I do not know much. But as the world is moving into smart, modern systems, Africa is still suffering from electricity access. We have 600 million people who cannot access electricity. So there is no way you're going to bring someone to a smart technology, yet they don't even own a proper fracture, infrastructure for the system. You get my point. So as the world is looking into many issues as climate change, there are other issues also like energy access, universal energy access. But the beauty of smart grid and why the global space is embracing smart grid is that you can include renewable energy resources, take care of electricity access, as well as combat climate change issues, as well as combat energy insecurities, as well as combat energy data security. All these issues can be integrated in a smart grid. I hope I'm being understood. So the space of how we are going to transition from fossils to renewable energy is very uncertain, and it is a space of each country's need. The needs of India, not the needs of Thailand. And as the energy sector, you cannot jump. So we must be very patient with this transition. We must be very patient. And as students, as we are studying, we must look beyond the global needs right now. We must also look into the next 100 years of the global needs, so that whatever innovation and whatever solutions we are giving now will cover thousands and thousands of years, to combat certain issues that may come that we may not know, because climate change is not the only issue. Yes, we are focused on climate change, energy insecurity, but we are bound to other issues that are known to any of us that are likely to come. So the transition is just a patient process. Thank you.
Thank you, ma'am. Any other question?
Shall I ask one question, ma'am? So, ma'am, shall I ask one question?
Doctor.
Can you focus on electric vehicles, how it is the better option? Electric vehicles, how it is the better option for the sustainable energy?
Okay, I will answer you on that. Now, electric vehicles are very important. Why? Because the whole concept of electric vehicles was based on carbon emissions. If we see on energy consumption, for all the energy demands, we all know that transportation takes almost 70% of the energy worldwide. And when you look at, even when they're doing emission studies, you will see that transport will cover the highest emission production. So first of all, electric vehicles were focused on carbon emissions.
Yes.
That was the concept. But secondly, it may not be affordable right now because not everyone can afford electric vehicles. But beyond its cost implications, beyond that, what benefits do we have? If we have low emissions, then that means we are reducing on climate change issues and any issues that are related to emissions. But way forward, it will also reduce at the rate people are buying cars and are using cars. Because if we have, for example, 10 electric buses in India, and they are prompt, they are well managed. There is no need for every Indian to have a car because we have a proper transport system where we do not have. That's why we have low energy utilization, low energy efficiency, low energy conversion. So the whole concept is to have less but quality. So electric vehicles, I think, are good future.
Thank you.
Thank you.
Thank you very much, ma'am. Thank you.
Thank you, ma'am. One last question from participant. Which renewable energy source is the best?
Oh, wow. What a wonderful question. I will not say that there is any renewable energy that is best. It is all based on management. I believe even fossil fuels, if we had managed them well, if we had systems that could combat carbon emissions, we would say fossil fuels are the best because they give us the highest energy input, right? So I cannot say that hydro is the best. I cannot say solar is the best because if I say it is the best, then Denmark will challenge me when it comes to solar because they receive the less sun. So it's about the management of the resource and the availability of that resource in that country. For example, India cannot start, I don't know, I'm just giving an example. If you do not have enough biomass, you cannot start planning for biomass, right? So there is no renewable energy that is better, but it is the management of the resource in that country. Not all countries have biomass, not all countries have solar, not all countries have hydro, not all countries have wind, not all countries have geothermal. So it is the management of the resource available in that country for the better results of that resource. That's why we have sustainable energy management right now that is gaining global recognition because it's not about which resource is better, but what is the sustainable system that you have in place to make that resource better. So I think I can't say hydro is better. I can say that for Uganda because we have a lot of water resources and hydro is, the priority for electricity and solar, but I cannot say that for Thailand, neither can I say that for India. Thank you so much. I hope I've answered you.
Thank you, ma'am. You are really clear all the doubts of the participants. Now, I think we should move to the last part of this program. Before this, there are few instructions for our participants. The first instruction is that all of you should please fill the feedback form. The link is being provided in the chat box. The submission of feedback form is mandatory to receive the e-certificate. Second instruction, please don't leave the WhatsApp group unless and until you will obtain the certificate on your registered email. You will receive this e-certificate within 2 to 3 days. And still then if you are having any problem, you can write us on WhatsApp or you can contact us. So now shall we move to the last part of this program, sir? So now I request our head of department, Professor Dr. S.R. Suraka sir, to present a vote of thanks. Over to Suraka sir.
Thank you, Amol. Good morning to one and all. Invited speaker, Miss Atwongyeire John Rose, Geoscientist, Prince Songkhla University, Thailand. Dr. Arkom from PSU, Thailand. Our principal, Dr. K.S. Wani, Vice Principal, Dr. S.P. Shekhawat, Convener of the program, Dr. P.J. Shah, all HODs anchor Mr. Amol Wani, and my dear students. Today, we have organized and conducted this online international seminar on energy transition and energy technologies for the budding engineers at the global level. I, on behalf of Electronics and Telecommunication Engineering Students Association, Electronics and Telecommunication Engineering Department, SSBT's College of Engineering and Technology, Bambhori, Jalgaon, extend my hearty vote of thanks to valued invited speaker, Ms. Atwongyeire Rose, for gracing your important work and sharing with us your findings and opinions today. A big thank for her efforts towards energy transition and energy technologies. I would also like to thank Dr. Arkom from PSU Thailand. Without his support and help, it is not possible to organize this event online. I would like to extend my sincere thanks to our inspiration, the governing body chairman, Mr. Rausad Shekhawat, who always motivate us to conduct this type of the events for the students. Actually, it is our commitment of the Department of ENTC Engineering, SSBT's College of Engineering, to organize the student-centric programs at various levels. And in this sequence, we have, in this pandemic also, organized from last 1 year, various programs for the students and the faculty and fraternity of the engineering. I would like to extend my sincere thanks to our beloved principal, Dr. K.S. Wani, who always support for organizing this type of the events. I also would like to extend my sincere thanks to Vice Principal, Dr. S.P. Shekhawat, all HODs, convener of this program, Dr. P.J. Shah, and Mr. Amol Wani, who taken the tireless efforts for organizing this program. And last but not least, I would like to thank all the participants, dear students. Your active participation motivate us to organize such type of program. So thank you very much once again to all.
Thank you, sir. Thank you very much. So, with the kind permission of our speaker, convener, our HOD, shall we close this program, sir? Shall I end the meeting?
Yes, sir. Yes.
Yes. You can end the meeting. Thank you. And this will continue till the end of the day for all the students, for their interaction, and they should not leave the group before getting the certificate. So this will be the total today's event, and throughout the day up till the end of the day today, you can send your feedback. Without feedback, you will not get the participation certificate. Okay, thank you. End the meeting.
Okay, thank you. So on behalf of ITSA, I once again thank you all. And now it's time to end the meeting. Thank you.
Thank you. Thank you. Sir.
Thank you very much.
Thank you.
Thank you, sir.
Thank you, sir.
Thanks so much, sir. See you
Thank
soon.
you, sir. Thank you, sir. Thank you.
Thank you.
So
Thank you, Dr.
we will see you soon. See you soon.
Yes, see you soon.
Ma'am,
Take
best
care,
wishes.
sir.
Best wishes.